Welcome to our webinar entitled Accelerated Aging, Key Variables in ASTM F1980 Testing. And hello, I am Tim Eels, and I will be your moderator and webinar organizer today. But before we start, let's just take a moment to make sure everyone is ready and familiar with the webinar control panel. First, you should have a control panel on the right side of your screen, which you can minimize by clicking on a little orange arrow button in the upper left corner. You may also expand that panel by clicking the same button. Also, you can submit questions using the chat pane located near the bottom of that control panel. And we'll have time today to answer a few questions. However, if for some reason we're unable to address the question that you post on the webinar in that chat window, we will follow up with you by email afterwards. For those of you registered and logged in right now, you can download a copy of the slide deck. Look for it in your webinar control panel. Okay, well, let's go ahead and get started. First, I want you to know that we're very fortunate to have a highly qualified presenter today, and that is Mr. Greg Schwinghammer. Greg is our principal engineer here at Westpac. He's got over 23 years experience at Westpac, and he's recognized internally and externally as a technical expert in accelerated aging and every kind of test that we do here. Greg serves on ASTM committees. There's 3 of them that he's on right now. D10 for Committee for Packaging, F02, the Primary Barrier Packaging Committee, and lastly, E60 on Sustainability. Greg constantly provides guidance and consultation for existing clients, partners, and internal test teams. And most recently, he completed a 10-year assignment as general manager of our San Jose lab. And during that time, he maintained and was actively involved in all things testing related to the technical side, especially the protocols and the products. Greg has a BS in packaging science from San Jose State University. He also has a packaging dynamics professional certification from the ISTA. So Greg, with that, I'm going to turn the webinar over to you and you can get started.
Great, thanks, Tim. Hopefully you're all interested in ASTM F1980 accelerated aging formulas today. This is going to be a fun one. First, I'll give you an overview of Westpac and what we do. I'll talk a little bit about the ISO 11607 process, and then we'll go through some key terms and variables related to ASTM F1980, and then the formulas, and then talk a little bit about relative humidity. Exciting stuff, I know. First, Westpac was founded in 1986. We're an independent testing laboratory based in California, but we have a global reach. We have clients all around the world. We have 38 years of experience. We do over 3,000 tests a year. That may not seem like a lot, but each test we do is based on our customers' needs. So we sit down and we work with them to determine what they need and then write the quote from there and conduct the testing based on that. And we're 100% employee owned. So every time you talk to somebody at Westpac, you're talking to one of the owners. We have 2 locations, one in San Jose, California, and one in San Diego, California. We're ISO 17025 accredited at both locations. You can see our A2A certification numbers there. And both labs are also ISTA certified. So we can run most of the ISTA tests. There's only a few oddball tests that we don't run, but call us and we'll see if we can run them and get certified for them before we do. With that, let's jump off on accelerated aging. ISO 11607 has a lot of different components. It has a manufacturing component. It talks about sterilization. It talks about distribution. And then it talks about shelf life, which is what we'll be focusing on today. And then the last mile. And then when your customer opens it up, either in the operating room, in the doctor's office, or at their home, is the product still sterile? How do you make sure that that shelf life, when you say it's 2 years of shelf life, is actually reasonable and accurate? So Westpac can help you with the distribution portion of the testing, the shelf life testing, and the last mile. We have partners that can help you with sterilization and manufacturing. So if you're looking for people to help with that, please give us a call and we can guide you in the right direction to help meet those needs. Went too far. ASTM F1980 is the standard guide for accelerated aging, sterile barrier systems, and medical devices. This guide provides information for developing accelerated aging protocols to model the possible effects of the passage of time on sterile integrity of the sterile barrier system. And that's defined in ISO 11607 Part 1 and the physical properties of the components packaging materials. Guidance for developing the accelerated aging protocols may also be used for medical devices and medical device materials, not just the packaging. Information obtained using the guide may be regarded as sufficient evidence for experimentation data claim or expiration date. I have trouble with that one. Expiration date claims for medical devices and sterile barrier systems until data from real-time aging studies are available. So if you do accelerated aging, you also must do real-time aging to validate the claims that you've found using accelerated aging. The accelerated aging guidelines address the sterile barrier system as a whole with or without devices. Devices and material compatibility are not covered by ASTM F1980. So if you're trying to determine is your product affected by the materials, you need to do compatibility studies in addition to the accelerated aging. Real-time aging protocols are also not covered in ASTM F1980. However, it is essential that real-time aging studies be performed to conform with accelerated aging test results using the same methods of evaluation. So let's talk about some key terms for accelerated aging. Accelerated aging is the storage of samples at elevated temperatures to simulate real-time aging in less time. So it's trying to get stuff to market faster. The accelerated aging factor is the estimated or calculated ratio of the time to achieve the same level of physical property change as a sterile barrier system stored at real-time aging. Accelerated aging temperature is the elevated temperature at which the aging study is conducted, may be based on the estimated storage temperature or the estimated usage temperature or both. Accelerated aging time is the length of time accelerated aging is conducted. Ambient temperature, or TRT, is the storage temperature for real-time aging samples that are typically for storage conditions. Also, the temperature used to calculate your aging duration. And your sterile barrier system shelf life is the amount of real time that the sterile barrier system can be expected to remain in storage at ambient conditions or under specified conditions of storage and maintain its critical performance properties. So how long can you store it for? And then real-time aging is the time samples are stored at ambient conditions. So now let's talk about the formulas. There are two main formulas that are used for accelerated aging calculation. The first calculates the accelerated aging factor, which is the more complicated formula, and we'll dig into the variables on that one. And the second is the accelerated aging time. So you take the desired real-time aging and divide it by the accelerated aging factor that you calculated above. So let's take a deeper dive into these formulas. The first is the accelerated aging factor formula. Per the guide, a conservative accelerated aging factor must be used if little is known about the sterile barrier system materials being evaluated. More aggressive accelerated aging factors may be used with documented evidence to show correlation between real-time and accelerated aging data. So if you don't know your materials and you don't know your product, use a conservative accelerated aging factor. Now looking at the variables in here, the Q10 is a Q10 of 2 is recommended in the guide. This is because the guide recommends a conservative approach. It says if you want to use the different Q10, you need to model the kinetic degradation of your materials and that it is beyond the scope of this practice. So if you want to use a Q10 of 5 or 6, you need to have the data to show that that reaction rate is actually what you're seeing in the real-time aging world. The TAA, this is the elevated accelerated aging temperature at which the study is to be conducted. So it's the 50, 55, or 60 of the accelerated aging temperature that you want. The TRT is the real-time aging temperature. So what are your samples going to be stored at? Or what number do you want to use for that? The standard recommends a TRT between 20 and 25 degrees C. Most of our customers use 23 degrees C. So you plug those numbers in and you come out with an accelerated aging factor. Once you have your accelerated aging factor, it's a simple division problem at that point. So fourth grade math or third grade math, you take your desired real-time aging and divide it by your accelerated aging factor to get your accelerated aging time. So once you've done that, and it's easy math. Now, if you don't want to do the first accelerated aging factor calculation, Westpac has a tool to help you with that. And one thing I just saw in the chat, somebody noted that there are 3 dashes on the equal sign. So this is copied straight out of the standard. So I'll have to go back to the standards committee and ask them what's going on with that three line equal sign, because I'm not sure. That's interesting catch. Thank you for noting that. So now Westpac has a resource or has a calculator on our resources page on our website that will walk this through. So if you want to do 12-month real time and you're accelerated aging at 55 degrees C, and you want to do an ambient temperature of 23 degrees C, so we're going middle of the road for both of those, and we allow you to adjust the Q10 factor, so you can put whatever Q10 factor in there if you know a different one that you want to use, but we pre-populate it with a 2, and then you hit the calculate button. It comes out with those variables for 40 days of accelerated aging to simulate 12 months of shelf life, or 39.7 days. Westpac always rounds up to the next full day because we want to take a conservative approach with this. So now let's talk a little bit about relative humidity. So if we look here, this is what's called a psychometric chart. And I put this in because people think that 50 degrees C and 50% relative humidity is the same as 23, it's the same moisture as 23 degrees C and 50% relative humidity. It's not. When you look at the psychometric chart, and I know it's an eye chart, but you can kind of see the curved lines that go up. As you go up in temperature, to keep the same relative humidity, it's more moisture in the air. So the standard recommends between 50 and 60 degrees C and between 45 and 50% relative humidity. So it's kind of in a conservative area. It doesn't do really high temperatures and really high humidities because that may adversely affect the way your product accelerate ages. And the way I kind of remember this is I think of brownies because I like food, and the brownie analogy is if you look at the back of a box of brownies, it says cook the brownies at 350 degrees Fahrenheit for an hour. And you can put it in and you cook it at 350 for an hour and everything's fine. But oh my gosh, I got to get out of here in 45 minutes. So I look at it, I'm like, okay, well, I can probably crank it to 355 and reduce it down by 10, 15 minutes and everything will be fine. You know, they might be a little soft, but you still got good brownies. But I'm like, oh my gosh, I got to get out of here in 15 minutes. I crank my oven all the way up to 500 degrees Fahrenheit and I get it out in 10 minutes. And what do I have? I have a charcoal briquette on the outside and goo on the inside. I don't have brownies. I have something I got to throw away and I got to stop at the store and wherever I'm going to pick up brownies. That's the same kind of theory with the accelerated aging. If you don't know the characteristics of the materials you're working with, go conservative, go longer durations, go lower temperatures, go lower real-time aging temperatures. That way you have the most conservative approach you can. I just love brownies, but anyway, back to the regular scheduled program here. Um, with that, let's kind of go over a summary of what we talked about. You need to know your materials characteristics before you determine your accelerated aging temperature. If you don't know those characteristics, use a Q10 of 2. Because if you don't, when you get to your submissions, you're going to have to write, or you're going to have to write either way, a justification of why you chose something different. And you want to use an accelerated aging temperature as recommended by the standard between 50 degrees C and 60 degrees C. If you're going to control humidity, use the standard recommended 45 to 55% relative humidity. And we age these in our stability and or accelerated aging chambers here at Westpac. We have over 40 of them at both sites. So we can, if you for some reason want to do 43 degrees C and 70% relative humidity, we have that capability here. We have enough chambers and enough places to go that we can do the variables to help you out. And remember that you need to do real-time aging in addition to accelerated aging. It's required to validate your accelerated aging data. Tim, do you have any questions?
Greg, thanks. That was a really good presentation. I like the brownie piece that you threw in there. Anybody done sterile brownies before? Is that no? I don't think we want
I don't know.
sterile
Maybe
brownies.
maybe space brownies if they're going into space with the astronauts, but I don't know. I've never seen sterile brownies. I'd love to give them a try. I'm always up for a brownie.
Brownies in the operating room, huh? Greg, somebody had a question about Q10. I know you explained it pretty well, but somebody actually wrote in. They ask, what if I use a different Q10 than the standard recommends, which is 2?
Yeah. Back to what I said before, if you use a different Q10, you have to justify why you're using it and know your materials, and that reaction rate is what your materials will actually see in the real world.
Okay. Yeah, I think you covered Q10 and pretty good. Oh, it's Greg, a question I was curious about. How often does Westpac see somebody using something other than 2 for Q10?
I would say it's less than 1%. It's the rare occasion we see a Q10 factor different than 2, because most people stick to what the standard recommends.
Okay. Sounds like just stick with 2 and you're going to be good. Greg, somebody has a question about running accelerated aging. I guess they're in a hurry at 80 degrees C and 50% RH. Does that make sense? What do you think about those numbers? 80, 50.
80-50, I think that is high for the accelerated aging temperature. And again, the humidity is there's going to be a lot more moisture at 80-50 than 50-50. So if that customer called me, I would ask them, hey, why are you doing 80? Do you know your material characteristics? What what is the purpose of this? Because you don't want to just use a higher temperature to get a shorter duration to try and get your stuff back quicker, because you're going to end up damaging the product or damaging the packages beyond what you would see with a normal reaction rate. So I would ask a whole bunch of questions, but at the end of the day, if you want to do 80 degrees C and 50% humidity, we'll do it for you. It's not recommended, but we have the capability to do it.
Greg, thanks. A good answer. How many years has Westpac been doing accelerated aging? Sounds like in your 23 years, sounds like you've seen a few accelerated aging jobs.
Yeah, we've been doing it for at least as long as I've been here, so 23 plus years. I remember when we first started doing accelerated aging, we had one or two chambers, and now we're up to over 40. So it's a growing business, but it's it keeps going and growing, and it's interesting to see how the standards changed over the years.
Well, cool, Greg. I had a question after that, but somebody wrote in here as about real-time aging. Have you seen or done a 5-year real-time aging equivalent of for accelerated aging?
Yes, what I've seen over the last few years are people are extending their shelf lives out. So when I first started, it was 1 and 2 year, and then for the longest time, it was up to 3 years shelf life. And now people are extending it out to 4 and 5 year accelerated. But the thing to remember is if you're extending your shelf life out that far, you have to have real-time aging data to back that up. And it's really interesting to see stuff come out after that's been here 5 years and try and find the person at the company, because people change jobs all the time. And it's interesting to see the ins and outs, and people will leave companies and come back, and you'll call them. And it's like, oh, that's no longer my study, even though I'm back at the same company. You need to call the person down 2 cubicles down. So just remember, when you're doing 5-year accelerated, you also have to do the 5-year real time. But yes, we have seen 5-year.
Cool. And you didn't mention it, but Westpac has real-time aging facilities. Is that right?
Yes, we have probably 8 to 10,000 square feet across both sites, or cubic feet across both sites, to do real-time aging. I don't know the exact number off the top of my head. I know we've added more capacity in San Diego recently, so it may be up to 15 to 20,000 square feet of real-time aging. But don't quote me on that. If you want to know the exact number, ping me and I will get it for you.
But from what you just said, some of the samples in there have been there for more than 3 years.
Yeah, we've had samples in there. We've got 5-year aging studies going right now. And when I was doing testing on a daily basis, I would start 5-year studies, and I would pull them out 5 years later. And it's like I said, it's been interesting to see the shelf life durations grow.
Wow, fascinating. Greg, we've got time for one more question. Um, in fact, it's about real-time aging. Does ASTM F1980 mention or include requirements for real-time aging?
ASTM F1980 refers you back to ISO 11607, that says you have to do real-time aging studies to make sure that your results are valid from your accelerated aging studies. So it's not called out specifically in F1980 what the requirements are for real-time aging, but it refers you back and says you should do those studies.
Okay, Greg, thanks. We've got enough time to just wrap this webinar up. I wanted to let everybody, first of all, I wanted to thank everybody who attended and submitting questions today. And if we didn't get to your question, uh, it'll be Greg that'll respond to you. So look forward to that. And there's 4 ways here you can connect with Westpac. You can use the request for quote link to ask a question about testing or even the webinar. But you can also use that for getting a quote or estimate for a testing job. We've got an 800 number you can use. There's a portal you can use, and even if you're not a customer or client, you can use that. And lastly, there's a email address, info@westpac.com. And references. The first bullet there is the link to the accelerated aging calculator that Greg showed you. We have a web page on accelerated aging. And lastly, a white paper. And you'll find that in our white papers link on our resources. 3 critical items you must know to plan and start accelerated aging for medical devices. And finally, I want to thank each and every one of you for attending today's presentation. We'd like your input on how you like today's webinar and what other topics might you be interested and need information about. Greg, we'd like to understand what you need so we can serve you. So expect a 2-question survey shortly, and please respond to it. And again, thank you all for attending. I am Tim Eels, your moderator. Make it a great day.